integer x equal to 10, string y equal to hello. Suppose if I write, what is int data type? What is x variable? What is 10 literal? What is string class? What is y object reference? What is hello object? Okay. Can I call this is data type? Yes or no? Yeah. Only string literal only object. Okay. Is it primitive type variable or reference type variable? This one, what it contains? Data 10. What it contains? Hash code. Here, system.out.println x. It contains data that is 10 printed. System.out.println y. It contains hash code, but output is hello. How? I'll explain. File, save. Don't write this one. Don't write. Say Java C demo.java, Java demo. Say you are getting hello, but it contains hash code, but you are getting hello. Not only like this, if you write like this also, what y contains hash code, but if I print hello, compilation, execution. Okay. Now I have to explain why. I have to explain. First of all, listen with more concentration. It is most important concept. Here, string s1 equal to hello. If I write in this line, how many objects are there? How many objects? One object. Where is the object? Hello is the object. Okay. This statement creates one object, one string object in a string constant pool. String constant pool is on memory block. Okay. This statement creates one string object in a string constant pool. So what will be happen is one object created, string object. This object contains hello. This object referred by S1. It contains hash code. Where it is created in a string constant pool created. It is one memory block. Something. It is string constant pool. Like this, done. First you write this one. If you write string s1 equal to hello, if you write this statement creates one string object in a string constant pool. It is one memory block in the heap area. Strings are stored here. This is string constant pool. In that one string object created that is contains hello, that is referred by s1. S1 contains hash code. Is it over? Now, suppose if I write like this, string s2 equal to new string s2, string s2 equal to new string s. Here, suppose if I write welcome, if I write, what will happen is in this line, how many objects are there? Two objects. This statement creates two string objects. One object created in string constant pool and one more object created outside the pool. So if you write like this, what will happen? See, one object created inside the pool, one more object created outside the pool, two objects created. It is inside the pool, one is outside the pool. Here, welcome. This welcome only placed here. This is string constant pool. This is also string object, but outside the pool. This object referred by S2. Okay, like this. If you write like this, you observe string object, S2. If you write like this, two objects created. One is inside the pool, one is outside the pool. With this one only you can understand strings. That's what it is required. This knowledge is required. Note on this diagram. This statement creates two string objects. If you write like this, two objects created. Welcome itself an object, new constructor, one more object. So this statement creates two string objects. One object created in string constant pool and one more object created outside the pool. So it is string constant pool. Here one object created. Outside the pool, one more object created. This object referred by S2. What S2 contains? Hash code only. It contains hash code. One note. Duplicates are not created in string constant pool. Duplicates are not created in string constant pool. Duplicates are not created in string constant pool. I'll explain what is that. Duplicates are not created in string constant pool. Is it over? See, suppose if I write like this, string S1 equal to hello. In this line, how many objects created? One. How many? One. If I write again string S2 equal to hello, then it won't create. Already hello will be there in constant pool. That is only referred by S2. If I write one more hello, it won't create. Now, how many objects created? One only. That object only referred by S1, S2, S3. Same hash code present here. That is duplicate concept. Okay. Here only one hello. When this line is executed, hello created in constant pool. That is only referred by S2. That is only referred by S3. This is not created one more object. Okay. Suppose if you write like this, new string hello. If you write like this, in this line, how many objects created? Two objects. Where it is created? One is inside, one is outside. Okay. But if you write again new string hello like this, outside only created, inside not created. So in this line, how many objects created? Two objects. In this line, how many objects created? One created. Because in a constant pool, duplicate not created. Now in this line, not created, no object, because that is constant pool. Suppose if I write like this, one created. Now these three statements, if it is executed, total how many objects created? Four objects. One is inside the pool, three outside the pool. Okay. This concept required to understand Java library. Okay. Now remember. Now here this library you can see at the command prompt. This library you can see in Java documentation also. If you type in Google directly java.lang.string, if you type, see it is string class profile, version 20 if you write 20 version string class comes. See first one only here. If you click here, Okay, that is API 20 may comes. Okay, now this is the 11th version updation is there. Okay, now it is string class profile. You observe in this class one variable is there. Okay, here constructors. See, constructors. Each constructor what purpose description also is there. Each constructor what purpose description also is there. You observe it is the fields nothing but variable description. Here constructor, every constructor one description is there. You observe what purpose also. Like that after constructor methods, this method what purpose, this method what purpose, this method what purpose. That is complete description available. But this profile we can see at the command prompt also. There is one command java p java.lang.string. All it is showing. Now first you should know about this java p product. Java p. It is called as JDK tool and it is used to get the profile of a class or interface. Java P. It is called as JDK tool and it is used to get the profile of a class or interface. It is called as JDK tool and it is used to get the profile of a class or interface. It is called as JDK tool, like a Java C, Java, Java P. Java development kit with the Java software, this tool comes. Here, well, for compilation, you'll write Java C. For execution, you'll write Java. Java C also JDK tool. Java also JDK tool. And this Java P also JDK tool. It is called as JDK tool and it is used to get the profile of a class or interface. Profile. What is profile? Profile contains list of variables, comma, methods and constructors. Profile contains list of variables, methods and constructors. Profile contains list of variables, methods and constructors. Profile contains list of variables, methods and constructors. Say, this is nothing but tool. With this, what we can do? We can get the profile. Profile nothing but variables, methods, constructors. Example, at the command prompt, we'll write like this. Java P, java.lang.string. It will display list of variables, methods and constructors of java.lang.string class. It will display list of variables, methods and constructors of java.lang.string class. It will display list of variables, methods and constructors of java.lang.string class. So after Java P, whichever class you write, that class profile comes. Profile nothing but variables, methods, constructors. Whichever class you write, that class profile comes. It will display list of variables, methods, and constructors of java.lang.string class. Is it over? No. Now you observe at the command prompt java p java.lang.string. See here. This is string class profile. Java p java.lang.string buffer class profile. See java p java.lang.string builder class profile. Java p java.util.string tokenizer profile. Like this. Any profile you can get it. But what is the problem is, suppose this is a method. This method what purpose? Description not there. That is available here in documentation. Okay. Write that point also. Descriptions of variables, methods, and constructors available in Java API documentation. Descriptions of variables, methods, and constructors available in Java API documentation. Descriptions of variables, methods, and constructors available in Java API documentation. See, if you write here, Java API documentation available in internet. Okay. If you open Java API documentation, that profile you can see. Description, every variable, every method, every class description will be there. But present as a beginner, these all not possible to you. Just information I provided. Now what I'll do, which method required I'll give, which class required I'll give, which package required I'll give. With that you have to write program. First that knowledge is required. Okay. Which method required, which class required, that is present you cannot understand. That is code Java should be completed. Then you can search. Present, if I give everything, you should be able to write program. That knowledge is required. Okay. Now, here you observe demo t equal to new demo. All right. Here, which class object created? Demo class. That object referred by D. What D contains? Hash code. System.out.println D. Now, you observe. File, save. Compilation. Execution. See, you are getting class name at hash code in hexadecimal format. Number formats will be there. Decimal, octal, hexadecimal, binary. So it is hexadecimal format number. Like number formats comes in the wrapper classes time. Class name. So this object refers which class? This object refers which class? Demo class. That demo printed, at symbol printed, hash code in hexadecimal format printed. Actually, every object has an address. Are given starting while teaching object. Every object has an address. The address mapped into another code. That code implemented with hashing technique. That code is called hash code. That hash code hexadecimal format coming. What is hashing also required? That in further sessions comes. What is hashing? Why do we need hashing? Everything. Okay. Like this printed. But with this, we cannot do anything because no pointers in Java. Pointers are there. We can perform operations on memory. No pointers. Security purpose removed. So we cannot do anything. But same style string yes equal to new string. I'll write string s equal to new string system dot out dot println yes. I'll write now in this line which class object created? String class. That object referred by what it contains? Hash code, but hash code not printed. See, file save. You will get a blank space. See, one blank space you are getting extra. Okay. Here, the here object created, that object referred by S. S contains hash code, but you are getting output blank space. Here object created, that object referred by D. D contains hash code, you are getting hash code. But why we are getting here a blank space? Why we are getting hash code here? I have to explain. Okay. For this, first, before this, some more points required. Note down. Java.lang is a default package and it is implicitly imported in every Java program. Java.lang is a default package and it is implicitly imported in every Java program. Java.lang is a default package and it is implicitly imported in every Java program. Java.lang.object class is a default class and it is implicitly inherited in every Java class. I'll explain, write it. Class name is object. Class name is object. It is in java.lang package. Java.lang.object class is a default class and it is implicitly inherited in every Java class. Java.lang.object class is a default class and it is implicitly inherited in every Java class. One more. ToString method is a default method and it is implicitly called whenever an object or object reference is passed as a parameter in a method. ToString method is a default method and it is implicitly called whenever an object or object reference is passed as a parameter in a method. These 3 points required to understand that one. So one default package is there, one default class is there, one default method is there. Is it over? See, 3 points are given. With these 3 points, why we are getting hash code, why we are getting blank space, you will understand. Now, in a Java library, hundreds of packages are there. Hundreds of packages, but one package default. One package default. That is java.lang. It is implicitly imported in every Java program. Every Java program, java.lang comes. In a Java library, thousands of classes are there, but one class, default class. That class, object class. This class available in java.lang package. This class implicitly inherited in every Java class. Every Java class inherited. In a Java library, lakhs of methods are there, but one method, default method. It is implicitly called whenever an object or object reference is passed as a parameter in a method. Now, see, observe here. This is one Java program. In this program, one package implicitly imported. Which package? Java.lang. Import java.lang.star. If I write, any effect will be there? No, that is no need to write. By default comes. Okay. This line no need to write. If you write also, nothing will happen. There is no effect. There is no effect. Whether you write or not, it will come. Okay. That is. Second point here. Java.lang.object class is a default class and it is implicitly inherited in every Java class. So here implicitly extends object. It doesn't appear, it is there. So welcome program only inheritance is there. Do you know? Welcome program only inheritance is there, but it doesn't appear. Here, this is no need to write. This is no need to write. If you write also, there is no difference. If you write also same. If you don't write also same. So this package, listen with more concentration. It is most important also. Okay. This package implicitly imported in every program. Every program import java.lang.star semicolon implicitly comes. If you write also, there is no difference. Okay. Every class extends object. Every class, either directly or indirectly, object class inherited. So extends object will be there. But one more point. ToString method is a default method and it is implicitly called whenever an object or object reference is passed as a parameter in a method. Now, this is, you observe, what is S? Object reference. What is println? Method. Here, it is parameter, no? So, object reference passed as a parameter. Parameter or argument, both are same. Actual argument, formal argument, parameters, both are same, I said, no? So, here, S is a object reference passed as a parameter in a println method. Then, implicitly ToString. This is the point. ToString method is a default method and it is implicitly called whenever an object or object reference is passed as a parameter in a method. Here, S is the object reference passed as a parameter to println method. Then implicitly .ToString called. If you write also, no difference. What is D? Object reference. What is println? Method. This object reference as a parameter passed here also. Here also implicitly dot to string. So you observe here. This is implicitly. This is implicitly. This is implicitly. This is implicitly. But not only these all, you'll studied some more also. Say one default constructor implicitly comes, no? This is default constructor implicitly. In that constructor, one word comes, super. That is also implicitly. This is all implicitly present. That is already you studied. I'll remove that one. Now these three now today you studied. This is implicitly. This is implicitly. This is implicitly. This is implicitly. If you write explicitly also, there is no difference. Previously, whatever we got the output, same output comes. You observe. This is output previously we got it. Now, after writing, file, save. Again, I'll compile. Again, I'll execute. Any effect is there? No. Okay. Now, here you are getting blank space. You are getting hash code. Blank space, hash code. But why we are getting here blank space? Why we are getting hash code required? Overloading, overriding. Have remembered or forgot? Remember no? Polymorphism, inheritance. All remember no? What is method overriding? Same name, same parameters list. Can we override methods in the same class? No. Can we override in inheritance? Yes. It is possible, no? In inheritance. If we create subclass object, if we call the method, subclass method called or superclass method called? Remember what you said. Overriding concept is studied, no? If the method is available in subclass, subclass method called. Not available, superclass called. Overriding. Latest one only called. Suppose A class, B class, C class. A class one show method, B class one show method, C class one show method. I'll create C object. I'll call show. Which class show called? C class not there. B not there. That is studied, no? So that is only runtime polymorphism, dynamic binding. Based on object comes binding. Now, here S dot to string. S dot to string. Now, S is a reference of which class? String class. In this class, toString method is there or not, we have to check. Okay. How to check? Just now you have seen profile. Java P, java.lang.string. Here, toString method, it is there or not, we have to see. Here, you observe. toString method is there, no? So, this method called. Now, in this program, in this year, toString method, which class definition called? String class definition called. Now, T is a reference of which class? Demo class. But in demo class, any toString method is there? Is there? But you are not getting error. No? But how it is working? Are you getting error? No. But yeah, it is working, no? How? Here in demo class not there. If demo class not there, where it will search? Object class. That is super class. So here object class toString method calling. You observe. Java P java.lang.object. In the object class also toString is there. So here you observe Here, which class definition called? String class. Here, which class definition called? That's what output different. That's what output different. In this method body, what they written is whatever is there in the string object that is printed. Like that code written. In this method body, what they written? Printing hash code written. That's what it is, printing hash code. That's what you are getting output different. Actually, what S contains? Hash code. But what is printing? Content. Content is empty. That's what blank space. You write here hello, out hello comes. You write here welcome, welcome comes. If you don't write anything, blank space. But here you are getting hash code. Because here definition different, here method name same, but different. Now you observe this part implicitly. This part implicitly. This part implicitly. This part implicitly. This is all implicitly present. Implicitly present. These are all implicitly present. Okay. Now, here, S is a reference of which class? String class. String is one class. Okay. Here, D is a reference of which class? Demo class. One minute. Here, string class. String is one class. Here, demo is one class. Okay. Now, S is a reference of which class? String class. Demo is a reference of which class? D is the reference of which class? Demo class. Demo super class is object class. Demo super class is object class. Okay. Now, it is super class, it is subclass. String is also one class, no? That class also super class will be there, no? Which class will be there? Again, object. Here. Object. Object. It is on super class. It is on super class. Here, in an object class, toString method is there or not? Yes, it is there. toString. String class, it is there or not? Yes, it is there. It is overridden. Object class toString method overridden in string class. In object class toString method is there. Is it overridden? No. Now, in this case, S dot toString. First it will search in string class. It is there or not? It is called. Here D dot toString in demo class is there? No. Then which is called? Object class. So in this line, which class toString method called? String class. Here object class. So this definition not same. Not same. What they written here to display content of object. Content of object is nothing. Blank space. That's what you are getting, blank space. Here what they written is to display hash code. That's what you are getting, hash code. Okay. Suppose, 1 minute. Suppose this method Myself, I'll override in demo class. Myself, I'll override. Then which method called? Demo class. Whatever you write the output, that output comes. So we can also override. We can also override. You can change the definition. Okay. Write this diagram. I'll give notes. Over. Here, s dot to string. This to string called. Here D dot toString, this toString called. Here toString method belongs to which class? ToString method belongs to which class? Object class. Already you studied. Over defined in subclass belongs to superclass. That word you studied, no? Object class ToString method overridden in string class. One method only having two definitions. One method only having two definition. One person only having two addresses. I give an example, no? So here object class ToString method overridden in string class. So string, it is two definitions, but method is one. One method having two definition. So string class ToString definition returns object, content of object. That is notes I'll give. Is it over? No done. String class ToString method definition returns content of string object. Whereas object class ToString method definition returns class name at hash code in hexadecimal format. String class ToString method definition returns content of string object, whereas object class ToString method definition returns class name at hash code in hexadecimal format. String class ToString method definition returns content of string object, whereas object class ToString method definition returns class name at hash code in hexadecimal format. Content of object, nothing, blank space. That's what blank space. Here class name demo at hash code in a hexadecimal format printed. So this definition returns content of object. This definition returns hexadecimal format hash code. Now object class ToString method can be overridden in demo class. Can be overridden by programmer in demo class to change the definition. Object class ToString method can be overridden by programmer in demo class to change the definition. Object class ToString method can be overridden by programmer in demo class to change the definition. See, string class toString method definition returns content of string object, whereas object class toString method definition returns class name at hash code in hexadecimal format. Object class toString method can be overridden by programmer in demo class to change the definition. Already what they did, object class toString only overridden in string class. They written. But now what you can do, you can override. You can change the definition. That is possible. Then you'll get a blank space also. Suppose first this program output, what we got it? Blank space, hash code in hexadecimal format. Okay. Now this is no need to write. This is not compulsory, no. It is implicitly present. Okay. Now file save, compilation, execution, blank space, class name at hash code in hexadecimal format you are getting. So here you are getting blank space. You are getting class name demo at symbol 5305068A. It is hash code in hexadecimal format. Okay. Now what I'll do is you observe myself, I'll override. If you want to override, first inheritance compulsory. Okay. Methods can be overridden only in inheritance. That point you study, no? But inheritance is there. Implicitly is there. That's what we can override. The method, if you want to override, it doesn't appears. It is there implicitly. Now, Java P Java.lang.object. This toString method I want to override. Overriding rules you studied. Now, this is I want to override. Overriding means method name must be same. Parameter list must be same. Return type must be same, except covariant return type. Access modifier same or less. Here, what is there? Public. Can I write protected? No. Can I write default? No. What we can write? Public only we can write. So I'm overriding now. Public. String. toString. Now, return type is string. Return type is string. Okay. What I will do is return empty.
Recording in
Now
progress.
you return this point, no? Object class toString method can be overridden by programmer in demo class to change the definition. I changed it. With this example, I changed it. Write this example. You observe. Now, object class is there, string class is there, object class is there, demo class is there. Now, in both the cases, two string methods are there. Here, two string. Here also two string. Here two string. Myself, I overridden. Here also two string. Now, here s dot two string implicitly. Here d dot two string implicitly. S dot to string implicitly. Here D dot to string implicitly. Now, here S dot to string. Which class to string called? String class to string. Here D dot to string. Demo class. That's what this output coming. Blank space, blank space. Ready, son? Overriding. Myself, I overridden. If you don't override, object class. If you override, your class. If the method is available in subclass, subclass method called. Not available, superclass called. That is only runtime polymorphism, dynamic binding. You already learned. Is it over? Say S dot to string implicitly, D dot to string implicitly, S dot to string. First it is search in string class. It is there. It is called. Here D dot to string. It will search in demo class. It is there. It is printed. But previous program, this to string method I didn't write. Previous program. That's what object class to string. Okay. Further, what will happen? You will create another class object. Another class object will create. Suppose string buffer or string builder or string tokenizer, any other class. You will create an object. You will pass as a parameter. If you are getting output hash code, then it is confirm object class called. If you are getting other output, then you have to check in that class. Not there, that's super class. Not there, that's super class. Not there, that's super class. Like that you can check. Somewhere it will be there. Because Inheritance, not only single inheritance, 10 levels also will be there in library. 10 levels also will be there. Multi-level, 10 levels also will be there. But if you are getting hash code, means confirm that is object class. That means in between there is no toString method like that. Okay, is it over? Now, suppose you observe, it is A class, it is B class, it is C class, it is D class. Okay, like this, 4 classes: A class, B class, C class, D class. Now, I written like this. Okay, suppose here by default object class also will be there at the top. Object by default. This class inherited here. Object inherited in A. That means inherited in B also, C also, D also. Okay, multi-level. Suppose here toString is there. Okay. Now here also overridden. Here also overridden. Here also overridden. Here also overridden. Now, what I'll do is D OB equal to new D. System.out.println D. I'll write. Which class toString method called? D class is called. Suppose there is no toString method here. C class. Here not there. Here not there. Here also not there. Object. Okay. Now, suppose here you don't know which class is there. Suppose this is, I have shown it is there. Suppose you created object like this, you passed like this. You got the output hash code. Then it is confirmed this is called. That means in between not there. You can understand. In between not there. If you are getting output hash code, that is confirm in between there is no toString. Okay. See. Suppose string buffer. I didn't explain. SB equal to new string buffer. If I create. First of all, this line valid or not valid required. Okay. If this constructor is there, valid. This constructor is not there, not valid. Got it? That is which constructor? Default constructor or parameter constructor? Default constructor. Default constructor implicitly present in program, a class. When it is present, if there is no other constructor, then only valid. Suppose I written like this. If I compile, if successfully compiled means that constructor is there in library. Okay. Now, successfully compiled. That means that constructor already present. Okay. I'll write system.out.println SB. If we get a hash code, which class toString? Object. If we get any other, that class, you have to search. Suppose compilation, execution. So here also blank space. That means in this class toString is there. Okay. Suppose string tokenizer. ST. New string tokenizer. Here string tokenizer class in which package? Java.util. It is compulsory to import. Now, if it is successfully compiled, this constructor is there. If not compiled, that constructor not there. You are getting error. That constructor not there. See, no suitable constructor found. Default constructor not there. Java compiler also will not provide Because already some constructors are there. You can see. Java P, Java dot, util dot, string tokenizer. Here, already other constructors are there. See, other constructor, other constructor, other constructor. 3 constructors are there. Parameter constructors are there. There is no default constructor. Will it Java compiler provides? Will it provides here? No, because already 3 constructors are there. Now, if you want to call only these 3, you can call. Suppose this one I want to call. I'll pass something hello. Will it compile? Yes. Compiled. Suppose system.out.println st. Now, if you are getting hash code means object class. If you are getting any other code means subclass. What you are getting? Hash code. In that class, toString not there. You can see not there. See, toString is there. This class profile is very less. You observe. Up to here, constructors only. After that, methods. toString is not there. Okay, that superclass. That superclass is not there. Nothing but extends object. In object class, that is hash code printed. Okay. Whenever you create any object here, that constructor is there, valid. That constructor is not there, not valid. If you are getting hash code, object class toString. If you are getting any other class toString. Like this, you can understand further. Okay. Tomorrow, I'll explain how to use string class library. Okay. This topic just to understand how to use Java library. Next topic, how to handle runtime errors. After that, everyday application. At that time, I'll give task, I'll give library, I'll explain. Then program you have to write. Okay, you prepare and be ready. Programs you have to write. Okay, we'll see continuation tomorrow.